Thank you so much. I'm very humbled to be standing here. I think I'm in a room of people who know a lot more about this topic than I do, certainly. So uh, we'll be happy to kind of give a little bit of perspective on what we're doing within AWS and why we think it's important that organizations do start to think about the adoption of quantum computing and how this will evolve over the next several years. A little bit more about myself. I don't claim to be an expert in quantum technologies. I do have a degree in theoretical physics, but that was a long time ago. But hopefully I can give you some insights onto what AWS is doing and why we think it's important to start now. So I did have one quick slide on what is quantum computing. I won't go through that in detail, but the one thing I've used in my own mental model about understanding quantum compared to digital computation is we're using the physical properties of objects. And when I've explained this to other people, I've used the fact that a prism naturally does a Fourier transform. So when you put white light through a prism, it breaks that light down into its individual frequencies, which is essentially doing a Fourier transform on that white light. So doing a Fourier transform inside a computational device would take quite a long time. Prisms does that instantaneously. So we do see that there are ways that we can use physical properties of objects to be able to do computation in different ways. I was reading at the weekend that there's now a chemical computer that's been released that works on essentially the mixing properties of chemicals, and they've now solved a traveling salesman problem by essentially using pots of chemicals with different mixing frequencies. So there are different ways of approaching computation, and we certainly see this as quantum as one of the key opportunities for us to evolve and be able to use quantum machines to solve those very specific problems that we see coming up. So a little bit about what we're seeing in terms of the adoption. There's really strong signals around optimization, computational chemistry, hybrid methods, which is around some variational technologies, and building expertise. So let me touch on some of those topics as to where they are. We do see this being applied across multiple areas within this. So within optimization is essentially a broad topic that allows us to solve problems about how we use assets or how we use environments. And one of the things that I do see quantum computing being used in is high-speed, large-scale optimization problems where you need to solve a problem quickly. We do have optimization techniques for solving things like workforce allocation to staffing, so places in hospitals, and even when we're trying to plan for school curriculums, they use optimization techniques to be able to solve those problems. The benefit at the moment for quantum devices is, can I solve those problems very quickly? Because that's the power that they have. So if you're looking at, for example, dynamic optimization of network traffic, then I believe that's one opportunity where quantum computing can be applied, because it can do that quickly enough that optimization is going to be effective over a classical computer. We also might see this around delivery, where we can dynamically optimize delivery in a city over time, so that we actually make sure that we're changing delivery based on arrival of packages as they come through. So again, that's an optimization problem where you need something to happen very quickly. The main class of problems that get solved is this quadratic unconstrained binary optimization, which essentially can be run directly on the D-Wave devices that we're connected to at the moment. And one of the challenges everyone's going to find is how do we map problems into that classical domain. So how do we understand how a problem can be represented or reframed into this cubo representation in order to be applied to a quantum device? And that's where a lot of the complexity with the work we see with the engineers working on quantum computing are going to spend their time. So we have a partner called QCWARE, which has been essentially working on a software as a service model that provides binary optimization, but they also do other features like linear algebra, machine learning, and Monte Carlo analysis. They essentially run their services on top of Amazon Braket. So let me touch a little bit about, as we got onto Amazon Braket, about what Amazon Braket does. So we launched Amazon Braket in 2019 as a way to provide the community of developers with access to quantum computing services. Our vision then was to democratize the access, make sure that anyone anywhere can get access to a variety of different quantum devices. It was to be able to blend classical and quantum computation together so that we can run problems that cover both domains. And we see this as being early on the most likely utilization of quantum computers is to be in collaboration or in connection with a classical device. And it was to basically allow experimentation so that people could use this very, very quickly, together with access to simulators. We've got 3 different simulators available now, which again can be used to make sure you can look at your computational models and see whether they can run. They are supported by a user experience, which is, if you're a developer, then it's probably relatively understandable. It uses Python. We have a packaged model called Penny Lane, which allows you to essentially use techniques that you're familiar with from a developer point of view to be able to gain access to those machines. The second area that we're seeing some opportunities in is in computational chemistry. Obviously, a quantum computer is able to simulate the structure and computational models for how chemical structures are put together. So we've seen some examples of this in the past where organizations have been able to do their own research on protein folding or on drug kind of research, and just in terms of finding those drugs. So we are seeing some benefits where that applies. It's been probably the earliest and most widely adopted area that we've seen around quantum devices at the moment. It's also used around machine learning and HPC classical solutions. Again, QBEC is a specific, again, partner that we have that's been involved in doing the back-end chemistry, so they can involve themselves in understanding how chemistry can be simulated with AWS. And this model essentially shows how QBEC provides this service to our partners or our customers who want to be able to use quantum simulation of chemical devices. The third area we're going to touch on is around variational methods. So this is probably something that's emerging now, and we're seeing ways of essentially looking at either machine learning or other techniques where the quantum machine itself is being assessed and then rerun multiple times against variational parameters to work out which way that they can optimize that. This obviously takes a lot more of the capacity of the quantum machine, so this is driving a substantial increase in the demand and access to quantum computers, because we're not just running a single model once and trying to run through and provide that. We might be running the same model 10,000 times through the device. So this is something that's really interesting, because I think it starts to understand how we might address noise within the devices, because they are still quite noisy and they are still quite challenging to very basically address those noise problems. But also the variational parameters then allow us to essentially run this and circle around to basically get the best optimization or best model of the way the computation works. And finally, in terms of building expertise, and this gets to the topic I'm going to touch on a little bit more, which is why start now. So, Alex touched on this as quantum computing is really very different to the way most people are used to when they're working with developers. We saw this with the introduction of even graphical processor units, when developers had to learn how to use those different ways of doing parallel computation compared to what they were used to with classical CPUs. It's a very different mindset about how to program those quantum computers and how to advise them. And we see the way this will work is that there will be a smaller group of people who will spend their time working at the very low levels, and they will create the abstractions, the ways to make life easier for other organizations. So the partners that we talked about this morning, just earlier about Horizon, for example, who are looking to develop ways of taking classical code and then implementing that onto a quantum computer allow us to essentially solve this problem of the skill set where people won't necessarily understand how the quantum computer devices actually work in practice. Nevertheless, because those once we understand what those opportunities are, that's where we'll see the innovation and the drive for that. So the early opportunities we're seeing at the moment is around providing training and enablement so people can understand how this works, allowing customers to do proof of concept studies, looking at larger scale nature-inspired optimizations that may be implied, and then working with researchers to ultimately build the expertise that we're seeing. Most of our customers are already starting with small proof of concepts to reproduce known results, and then they start to map those proof of concepts onto use cases so they can actually look at how they may scale these problems up. Certainly within Singapore, my view would be that we want to work very closely with QEP, A-Star, NSCC as the foundation for how they will be able to access quantum devices and quantum computation to be able to build on this experience. So really, the question is why now a little bit more. So the elephant in the room at the moment is that nobody really knows when quantum advantage will be found. It may be that someone will find a really cool way of developing a quantum computer that can be done at thousands of qubits and scale that within a couple of years. And once that's in place, then that will drive a differentiation and drive a really radically different landscape for the way that we see computation occurring. So we really want to make sure that people have access to the quantum capabilities so they understand the potential and the impact that will be there. So Michelle Moscow made this comment that we know these things will be a disruption. Disruptions will happen. There's a great risk of being not on point of just understanding what this might be and understanding what the opportunities might be. We've all seen organizations in the past who have not been following the technology or have even invented the technology and then not being able to take advantage of that, failing in their future because of the consequences of how technology has changed the way we think about the world. So what can be done today is essentially we can do design and test of basic solutions, running hybrid classical quantum workflows, small proof of concepts, pushing the boundaries of classical methods, and some of the variational techniques we've seen with the noisy quantum devices we have. And what we see tomorrow is larger, earlier adoptions. And again, I'd come back to the high speed optimization problems as being one class of area that I see as being a big opportunity, because that's likely to be something that we can gain business benefit given the speed that quantum devices can solve those optimization problems rather than waiting for a classical computer to come up with the same answer. We will eventually get fully fault-tolerant quantum computation. That will be quite a long way away, I think. But again, the way the research is happening, the speed and pace of advances means that we don't know when that will happen. So again, a little bit about why now. So I've probably touched on most of these points, but just the scaling of interest, the amount of government interest in this topic, the number of universities that are really focusing on quantum computation at the moment is very high. Starting from now really allows us to forward think and make sure that we understand the domain, looking at the transformational potential. In most cases, we won't know what the impact of this will be. So when we've looked back in the past at things like the introduction of the Global Positioning System, GPS, no one really thought that GPS would give rise to Grab and Uber and those ride-sharing, car-sharing devices. So those are the sorts of opportunities that we see coming out of adoption of these technologies. We can't predict what people are going to think of in 2 or 3, 4 years' time when quantum computing is becoming more prevalent. They will think of a new way of solving a problem or a new way of doing business that is going to radically change the way we think about it. The other benefit here of really starting now is to make sure that we do get this understanding of the mindset shift. It is really very radically different. It's hard to understand how quantum computation works. For anyone who's looked at in any detail, I'm sure you would agree that this is not an easy thing for most developers to understand. So the people who will eventually take advantage of this will probably be people who are going to have that background of just understanding how these things work. Just wanted to touch on a little bit more about what our customers are saying they want in quantum computing at the moment. So really it's an integrated approach. So this combination of classical and quantum computing is important. So we do see that this is the most important area where the combination is going to be how we see solving problems in the short term. The likelihood is that quantum computing will solve a very specific problem within a problem domain, and that the computation that goes around that, the classical computation that goes around that, will essentially solve the remaining integration problems as you break the problem down into smaller components that they need to be reintegrated back up into providing that answer back from a business point of view. And we touched on also already that the variational methods we have at the moment are seeing that this combination of classical and quantum computing is going to be the main problem solver. They're looking for an easy way to get started. So Amazon Braket provides that easy way to access. You can get access to multiple different types, and I'll touch on that in a second, multiple different types of quantum computation today with very little complexity. It does take a bit of knowledge to understand how the platforms work, but it's fairly straightforward. And most importantly, we provide access to multiple different quantum devices in exactly the same way. So you can apply the same domain problem to each of those devices. We pride ourselves on driving innovation. So one of the things we do allow these companies to do is once they can get access to these devices, they're able to then make sure they can experiment, they can develop proof of concepts, they can and then try to build on that today. And then finally, the confidence to invest. So we're trying to provide essentially a foundation. This is very early days for us in the quantum computing journey, as well as is for everyone else who's participating in this research. So we do want to make sure that we're providing that foundation so that our partners and our customers can start to experiment and use the technology itself. So this is a model of essentially what we have. We do have managed simulators, which allow you to basically run your quantum algorithms in a variety of different simulation models, which map to the ways that the quantum devices work. It's integrated back into the range of other AWS services, so CloudWatch, which provides monitoring, EventBridge, which does notifications, so it tells you when jobs are finished or and the like, and then storage in Amazon S3. We do provide access to, at the moment, we've got 4 devices that are now released. So D-Wave, which is a quantum annealing device, IonQ, which is a gate-based ion trap, Braket, which is a gate-based superconductor, and OQC, which is essentially another gate-based superconductor based out of the UK. QCWARE, which is a Rydberg atom quantum device, will be announced. I think it's been announced, but will be available later on this year. So all of these devices are accessible essentially today. Those 4 devices are accessible today. So we do see customers looking to experiment in understanding the relative strengths and weaknesses of each of these devices. As those of you know the space will know that D-Wave have got 1,000 qubit devices, not necessarily the same as a fully quantum computer, because they can't necessarily solve all of the problems, but they can solve those optimization problems. So just a little more on the Amazon Braket hybrid job. So we announced this at reInvent. So it's fully managed execution of custom algorithm code with quantum tasks, and we do put the job monitoring and build that stuff around the servers itself. So essentially, you can pre-built or bring your own algorithms to run on the quantum computers itself. So this is an extension of the services we're providing. So we're essentially here building foundations that make life easier for partners and customers to take advantage of those quantum hardware and quantum devices. So with that, I will do a quick summary. Quantum computing, as we're all aware, is radically different. It's something that's hard to understand and get used to. We are still very early in this journey of where quantum computing is heading. And AWS is committed to supporting democratized access to multiple quantum computing devices, enabling hybrid quantum classical workloads, and using a consistent experience supported by the AWS expert team. So we have both teams of architects that have been helping some of the teams in here working with quantum computing already. And we've also got a research center in the US, which is based on working with customers directly to do algorithms. In addition to that, we've done training here in Singapore of several tens of people in A-Star and NUS and other organizations that can then build on that experience and be able to build on the quantum computing devices. So I'll pause there and take questions if anyone has any questions. Oh, thank you.
There's a mic here.
You didn't mention the optical quantum computer. Do you have any comment why you are not using it? Maybe it's not available, or maybe it will not work.
So not available through us at the moment, no. But I do agree, and it's one of the reasons I was raising that the option that things like prisms provide that essentially foundational way of using different physical properties to do that. So yes, we do see. I do see optical computing as being an option that could come along. That if we can get access to that and provide that, then we would certainly do the same thing and add that. But that's probably not on our roadmap at the moment. Okay, there's no more questions. Oh yes, sorry, please.
Okay, thanks for the wonderful talk. So you talked about the service providing to the public through the various platforms. So do you buy the kind of like hardware, for example, D-Wave, they also sell their system, or do you just allow or help the customers to connect to the systems?
It's the latter. So if you are a researcher, for example, then you may find benefit of going directly to D-Wave or Rigetti or IonQ, so that if you want to get access to the devices or over a longer period of time. So we would encourage those people who need to access them directly from a research point of view to do that. The main value we provide is a layer of abstraction that just makes it easy for anyone to be able to access those devices. So maybe once you've got to the point of scaling or making these more industrialized or putting that with partners, then using Amazon Braket just makes life easier, particularly if you're combining things with high performance computing together with quantum devices, and or you want to be able to use multiple different quantum devices for different parts of the algorithm. So that's really the benefit of accessing through cloud and not necessarily having to have the whole device yourself. So I don't think anyone in this room is going to necessarily buy a quantum computer themselves. So we are providing that mediation of a very simple way of buying that service, rather than negotiating directly with each of those vendors as well. So you can actually just log on. You can basically run a quantum algorithm within a few minutes of logging on and creating your account, if you know what you're doing. Okay, thank you. I'll be around if anyone's got any other questions, and appreciate the time. Thank you so much.